Magandang araw! April Marcas po, ang inyong pretty ate sa Edtech Unit. Alam ba ninyo na may webinar o online training session ng Edtech Unit tuwing Sabado? Ang araw na ito ay nakalaan para sa ating mga mahal na kaguruan upang turuan sila ng mga bagong kaalaman at kakayahan sa paggamit ng makabagong software at applications para sa pinaka-epektibong paraan at lubos mapaghusay ang kanilang paraan ng pagtuturo. This is also a refresher session for our beloved teachers to enhance their skills in technology. Every Saturday, we will conduct webinar sessions for teachers about the use, advantages, and relevance of different blended learning software applications. Ang webinar seryeng ito ay magsisimula ng alas 9 ng umaga hanggang alas 12 ng tanghali para sa morning session. Magsisimula naman ng alauna at magtatapos ng alas 4 ng hapon ang afternoon session. You can watch us in our DepEd Edtech Unit Facebook page, Educational Technology Unit YouTube channel, DepEd Tayo, and DepEd Philippines. Kita-kits tayo tuwing Sabado!
Magandang araw! Sir Wilbur po, at your service. Narito ang ETUlay upang gabayan ka sa inyong pag-aaral upang lubos na maunawaan ang iba't ibang paksa o subject. Ang ETUlay ay isang free online tutorial class na pinangungunahan ng DepEd Educational Technology Unit sa pamumuno ni Undersecretary Elaine Del B. Pascua. Ang programang ito ay hindi lamang para sa mga bata, kundi ito rin ay magsisilbing gabay sa mga magulang at mga guro kung paano nila ituturo o gagabayan sa bawat asignatura ang kanilang mga anak o mga estudyante. Sa kasalukuyan, ang self-learning module mula sa rehiyon ng Calabarzon at kilala sa tawag na pivot ang ginagamit sa ating ETUlay online class. Kaya ano pang hinihintay ninyo? Ihanda na ang inyong mga ballpen o lapis, papel o kwaderno at samahan kaming itulay ang pagkatuto para sa bawat batang Pilipino. Sama-sama tayong magtutulungan para malampasan ang mga hamon sa panahong ito. Halina't matuto kasama ang inyong online tutor sa oras na ito.
Isang napakagandang Lunes na hapon sa lahat ng sumusubaybay sa atin dito sa ETUlay Senior High School Physical Science sa oras na 4 to 4:40 kada Lunes. Right, welcome to another ETUlay session. Tutor Lester po, at your service. So today we are on the third quarter, week number 6. Ang paksa po natin ngayong hapon ay limiting reactants and the amount of products formed na mula sa week 6 coverage ng pivot modules ng Calabarzon. The objectives for today's tutorial sessions are the following. Use stoichiometric calculations to determine excess and limiting reactants in a chemical reaction and explain why. Calculate theoretical yield of products formed in reactions that involve limiting reagents. Review po muna natin ang chemical reaction na ating natalakay noong nakaraang linggo. Ang nakikita nyo po ngayon sa screen ay nagpapakita ng parts ng isang chemical reaction. So we have the reactants on the left side of the equation and the products on the right side of the equation. So the reactants and the products are separated by, by an arrow. So on the reactant side, we have 4 atoms of hydrogen, which is a gas, colliding with 2 atoms of oxygen, which is also a gas, with enough force to start a reaction. So the reaction creates water, as you can see in the product side of the equation. Here is another chemical reaction sample. Here we have the combustion of methane in the presence of oxygen molecules that produces carbon dioxide and water. Yan. So let us get started with our topic na po. Right. So chemical equations give the ideal stoichiometric relationships of reactants and products. So however, sometimes the amount of reactants used are not mixed in exact or proper ratio. Ibig sabihin, after the reaction, may mga reactants na sobra o hindi nagagalaw at meron ding reactants na nauubos. So for this session, let us define the key terms that we will be using or discussing. So simulan po natin sa stoichiometry. So we have already encountered stoichiometry during our junior high school science, specifically sa chemistry. So stoichiometry is defined as the also the stoichiometry. This establishes the mole in mass relationship between reactants and or products in a chemical reaction to determine the desired quantitative data. So ang stoichiometry is more of the ratio of the quantities of reactants taking part in a reaction. Stoichiometry sets kung ilan ang quantity ng bawat reactant. So after a chemical reaction, there will be some reactants that will be left unreacted. So ito po yun ang tinatawag nating excess reagents or excess reactants. So ito po yung mga reactants na hindi nagagalaw or hindi nagagamit sobra during a chemical after a chemical reaction. So after the products are formed, some of these reactants are still found. The limiting reagent or reactant, on the other hand, this is the reactant that is completely used up in a chemical reaction. So matapos ang chemical reaction ay wala tayong makikitang bakas nito kasama sa product na nabuo. So nauubos po lahat. So and now that we had already defined the key terms in this topic, so let us discuss the essence of this session, the stoichiometric calculations. So the first step in stoichiometric calculation is to balance the chemical equation. So we are going to write a balanced reaction. Mahalaga po ang balanced reaction or balanced chemical equation dahil ang ratio ng mga reactants which are based on the stoichiometric coefficients will be used in the computation. Magiging mali po ang computation natin kapag nagkamali tayo sa stoichiometric coefficients. So ang nakikita nyo po ngayong reaction ay hindi pa balanced. So this is a reaction where propane or C3H8 is born in the presence of oxygen. So the reaction of propane in the presence of oxygen produces water and carbon dioxide. So ano po ba ang mga steps para ma-balance natin ang chemical reaction na ito? So, recalling from our junior high school science, ang pinakauna po nating gawin ay dapat isulat po itong equation gaya ng nababasa niyo po sa slide. So, let us write the reaction first. At kapag naisulat na po natin ang reaction, ang sunod naman po natin gagawin is to write down the number of atoms per element. So, paano po natin isulat? So, we can do this or maaari po nating isulat sa isang table ang number of atoms na makikita natin sa reactants at saka sa products. Kung ano ang subscript, okay, kung ano ang subscript na katabi ng isang atom, ay yun po ang number ng isang particular atom. So in the equation, we have the following numbers. So on the, okay, ang atoms po na makikita natin sa reaction are the following. Okay, carbon, oxygen, and hydrogen. So in the reactant side, we have 3 atoms of carbon. On the product side, we only have 1. In the reactant side, we have 2 atoms of oxygen. And on the product side, we have 3. Hydrogen, on the other hand, dito sa reactant side, we have 8 hydrogen atoms. And on the product side, we only have 2. Makikita natin na hindi pantay ang number of atoms. So in order to balance the equation, we have to balance the number of atoms in the reactant and the product side. Let us remember that we cannot change the subscript of the atoms found in the equation. So, hindi po natin maaring ibahin kung ano ang subscript na nakasulat sa mga atoms in the equation. So, in order to balance this reaction, what we need to do is add a coefficient or a number beside the atom. So ano po ang uunahin natin? Anong atom ang una nating babalansihin? So we balance first the other atoms before balancing hydrogen and oxygen. So unahin natin ang carbon, isunod natin ang hydrogen at saka na lang ang oxygen. So yes, so we'll start with carbon. So in the reactant side, we have 3 carbons while on the product side, we only have 1. So paano po natin maibalance ang carbon? Right? So tama po. So in order to balance carbon, we add a coefficient to the single carbon atom in the product side to balance the carbon in the reactant. So lagyan po natin ng 3 dito on the product side. So this 3 carbon in the product side changes the number of oxygen in the product side as well. So ngayon, before we added the number 3 coefficient, ang number of oxygen natin on the product side is 3. Now that we added the coefficient 3, so this number is multiplied to the atom here. So total na ngayon natin is 7 atoms of oxygen. All right. As I have said, we will balance oxygen later. Isunod po nating i-balance ang hydrogen. All right. So now we balance hydrogen. So on the reactant side, we have 8 atoms of hydrogen, while on the product side, we only have 2. So, paano po natin i-balanse ang number? So, saan banda po tayo maglalagay ng coefficients in order to balance the hydrogen atoms? Okay, so saan po tayo maglalagay? Okay, so tama po. So, we add the coefficient 4 or the number 4 beside the hydrogen in the product side. So, now, we multiply that coefficient with the subscript in the hydrogen, which is 2. So 4 times 2 is equals to 8. So does this balance the number of hydrogen atoms? Right? So yes, it does. So hydrogen atoms in both sides of the equation are now balanced or equal at 8. All right. So lastly, we balance oxygen. So ilang oxygen atom po on the reactant and on the product side. So as you can see in the table, okay, we have 2 oxygens here sa reactant side, and we have, okay, 10 oxygen on the product side. Okay, paano naging 10? All right, so 4, okay, 4 times 1, that is 4. Then add the number of oxygen here. So 3 times 2 is 6. So 6 plus 4 is 10. So as you can see, hindi po balanse ang oxygen dahil 2 dito sa reactant and 10 dito sa kabila. So how do we balance the oxygen atoms? So to balance the oxygen atoms, saan po tayo maglalagay ng coefficient? Okay, tama po. So we add a coefficient of 5 beside oxygen in the reactant side. And with that, we multiply that number to the subscript in oxygen, which is 2. So finally, balancing the reaction. Right. So ang nababasa po nating chemical reaction sa slide ay isa na pong balance reaction. So now that we had already balanced the reaction, we can now proceed to the next part. So the next part is finding the limiting reagent in the reaction. So always put in mind na in order to find the limiting reagent, we have to balance the chemical reaction. Right. So we have here an example problem. So the example problem goes like this. For the following reaction, what is the limiting reagent if we start with, all right, hindi po ito kilogram, this is just a typographical error. So if we start with 2.8 grams of aluminum and 4.25 grams of chlorine. So in the problem, we have aluminum and chlorine as the reactants. So we write down the reactants in an equation form. So paano po natin isusulat ang aluminum at ang chlorine reaction in the equation form? So ano po ang magiging kalalabasan if aluminum and chlorine reacts? Alright, so tama po. So the reaction of aluminum and chlorine forms aluminum chloride. So it is also known as aluminum trichloride. So this is now the written equation. Pero this is not yet balanced. So susunod natin gawin is to balance the equation. So this equation actually is not that complicated to balance. So madali lang pong i-balance ang reaction ng aluminum at chlorine, which forms aluminum chloride. Alright, so we balance aluminum first. Okay, so lagyan natin ng 2, okay, on the reactant and also 2 on the product side. So putting 2 puts the number of atoms in both sides of the equation balance at 2. So dahil nilagyan po natin ng 2 dito sa aluminum, beside aluminum in the product side, so this balances the chlorine atoms. All right, so we have 2 times 3 is 6. So in order to balance the chlorine atoms, so lagyan po natin ng 3 dito sa chlorine in the reactant sides, and that balances the reaction. So now that we had balanced the reaction, ang sunod po natin gagawin is we convert the amount of grams of aluminum and chlorine into moles. So paano po natin i-convert into moles? So to convert the grams of aluminum and chlorine into moles, we just follow the solution found or that you can read in the slide. So to convert aluminum, the grams of aluminum into moles, so we multiply the grams of aluminum as found in the problem, multiply it by the ratio of the 1 mole of aluminum, which is equal to 26.98 grams of aluminum. Alright, so saan po natin mahanap itong 26.98 grams of aluminum? So makikita po ito, this is the formula mass of aluminum. So we can check this one out in the periodic table. All right. So multiplying the grams of aluminum as given in the problem with this ratio, 1 mole of aluminum over 26.98 grams of aluminum cancels the gram unit. So ang natitira po ngayong unit is ang mole. So 2.8 divided by 26.98. So the number of moles found in the reaction is equal to 0.104 moles of aluminum. So in 2.8 grams of aluminum, there is 0.104 moles of aluminum. So do the same process for chlorine. So to convert the grams of chlorine into mole, so i-multiply po natin ang grams of chlorine as given in the problem by the ratio of the formula mass of chlorine to a mole of chlorine. So 1 mole of chlorine is equal to 70.90 grams chlorine. Okay, saan po natin makikita itong 70.90? So we can find this value in the periodic table. So multiply these grams of chlorine with 1 mole of chlorine divided by 70.90 grams of chlorine. So cancel natin ang grams. So what is left is the unit mole. So there is 0.0599 moles of chlorine in the reaction. So from the conversion values, we list the number of moles per reactant as follows. So aluminum is equal to 0.104 mole. Chlorine is equal to 0.0599 mole. So what's next? So after converting the grams of aluminum and chlorine into mole, is we haven't determined yet kung alin sa dalawa ang limiting o ang mauubos na reactant after the chemical reaction. At hindi pa rin natin na-determine kung alin dito ang excess reactants. So there are ways how to determine the limiting reagent in the reaction. So ang hahanapin po natin dito ay yung reactant na mauubos. So how to find the limiting reagent? So we will use the stoichiometric ratio. So method 1 of finding the limiting reagent is to use the stoichiometric ratio of the reactants from the balance reaction. So in this method, we calculate the actual molar ratio of the reactants. Then we compare this ratio to the stoichiometric ratio from the balance reaction. So how to do this? So how to compute for the actual ratio? So to compute for the actual ratio, ang gagawin po natin is we divide the moles of aluminum to that of the moles of chlorine. So 0.104 mole aluminum divided by 0.0599 mole of chlorine. So we have 1.74 moles aluminum per 1 mole of chlorine. So that means that the actual ratio is we have 1.74 moles of aluminum for every mole of chlorine. And then ngayon, let us now get the stoichiometric ratio of aluminum to chlorine. So remember, we base this ratio to the balance reaction. So in the balance reaction, there are 2 moles of aluminum and 3 moles of chlorine. So we divide 2 moles of aluminum with the 3 moles of chlorine, so we'll get the stoichiometric ratio of 0.67 moles. So there are 6.67 moles of aluminum per a mole of chlorine. So ano pong ibig sabihin nito? So this means that 0.67 moles of aluminum will react with a mole of chlorine to form aluminum chloride. So ulitin po natin. So there will be 0.67 moles of aluminum per mole of chlorine to form aluminum chloride. So if we compute, if we try to compute through ratio and proportion and using the ratio that 0.67 moles of aluminum is required to react a mole of chlorine, then then we will find it that for every 0.104 mole of aluminum, we will need exactly a 0.156 mole of chlorine. All right. Ilan lang po ang moles of chlorine ang available as given in the problem? All right. So according to the problem, we only have 0.0599 moles of chlorine, which means that mauubusan tayo ng chlorine reactants before all of the aluminum has been used up. So therefore, alin po dito ang excess reagent? Alin dito ang limiting reagent? So that puts aluminum as the excess reagent and chlorine as the limiting reagent. So, in the product side, wala na pong matitirang chlorine, but there will be an excess of aluminum. So method number 2, there is another way to find the excess and the limiting reactants. So we will try to choose one of the reactant as if it is the limiting reactant. So we'll choose one. So in this method, we assume that the aluminum is the limiting reactant. So because we assume that aluminum is the limiting reactant, so we get the number of moles of chlorine that will be required to react with aluminum. Right. So how to compute? So we compute the number of moles required to react with 0.104 moles of aluminum. So we multiply that by the ratio, by the stoichiometric ratio, wherein 3 moles of chlorine is equal to 2 moles of aluminum. Alright, bakit andito ang aluminum? on this in this position and bakit andito ang chlorine. Okay, so sadyang inilagay natin dito ang mole of aluminum in order to cancel, okay, in order to cancel the unit. So ang matitirang unit is the moles of chlorine. So 0.104 times 3 divided by 2. So we will find that for every 0.104 mole of aluminum is we need 0.156 moles of chlorine. Okay, so this is the very same amount that we came up with using the ratio and proportion. So, ayun na nga, base sa ating computation ay we could find it that mauubusan tayo ng chlorine bago pa magamit ang lahat ng aluminum. So, we still have the third method, that we will use in order to find which is the limiting reactant and which is the excess reactant. So, we will use the concept of a mole of reaction. So 1 mole of reaction is defined as occurring when the number of moles given by the coefficients in the balance equation reacts. Alright. So, okay, ganito po natin gagawin yon. So 1 mole of reaction basing on the balance chemical reaction na naisulat natin kanina. So 1 mole of reaction is equals to 2 mole of aluminum, which is equal to 3 moles of chlorine, which is equals to 2 moles of aluminum chloride. Right. So now, we convert these moles of each reactants to moles of reaction. So 0.104 mole of aluminum is equals to, okay, 1 mole of reaction per 2 moles of aluminum. So we have 0.0520 mole per reaction for aluminum. For chlorine, we convert the moles of the chlorine reactant to the moles of reaction. So we have 0.0599 moles chlorine multiplied by 1 mole reaction divided by 3 moles of chlorine. So we have 0.0200 mole per reaction. And looking at the figures, so the more moles of reaction you have, the more times the reaction can occur. So therefore, the reactants with the fewer moles of reaction is the limiting reagent. So this confirms that chlorine is the limiting reagent and aluminum is the excess reagent. Bakit? Because the reaction can be carried out fewer times with that of the reactant. So now that we have found the limiting reagent, we can now compute for the theoretical yield. So let's read the problem. What is the theoretical yield of aluminum chloride that the reaction can produce when we start with 4.25 grams of chlorine, our limiting reagent? So, paano po natin i-compute ang theoretical yields? So, we can use the moles of the limiting reagents plus the stoichiometric ratios from our balance reaction to calculate the theoretical yield. The coefficients from the balance reactions tells us that, okay, there are 3 moles of chlorine for every 2 moles of aluminum chloride. So therefore, the theoretical yield in mole is, so we have 0.0599 moles of chlorine multiplied by 2 moles of aluminum chloride divided by 3 moles of chlorine. So cancel natin ang moles chlorine. So what is left is the unit mole aluminum chloride. So we have 0.0399 mole aluminum chloride. So this is now our theoretical yield in moles. Okay, this is in moles. So we can also do we can also compute for the theoretical yield in grams. Why do we have to do the computation in grams? Okay, that is because the theoretical yield is expected to have units of mass. So, i-convert po natin ang number of moles of aluminum chloride to grams using the molecular weight of the aluminum chloride. So, according to the theoretical yield in moles, so this is the number of moles of aluminum chloride, 0.0399 moles aluminum chloride multiplied by, okay, 133.33 grams aluminum chloride. So, saan po natin kinuha itong 133.33 grams? So, this is the molecular weight of aluminum chloride. So, we can find this by adding the formula, the molecular weight of aluminum, which we can find in the periodic table, and the molecular weight of chlorine multiplied by 3. So, add the molecular weight of aluminum to that of the molecular weight of chlorine multiplied by 3. So, you will get 133.33 grams of aluminum chloride. Right. So, ang theoretical yields in gram is equal to 5.32 grams of aluminum chloride. So now that we have computed for the theoretical yield is we now get the percent yield. So why do we need to get the percent yield? So let us remember that the theoretical yield is the maximum amount that is expected from the reaction based on the amount of the limiting reagent. However, in practice, hindi po natin nakukuha ang maximum yield or the theoretical yield for so many reasons. So one of the reasons is purification. Since chemists knew that the actual yield might be less than the theoretical yield, so we report the actual yield using the percent yield as shown in the equation. So percent yield is equal to the actual yield divided by the theoretical yield multiplied by 100%. So we have here an example problem. The decomposition of magnesium carbonate forms 15 grams of magnesium oxide in an experiment. The theoretical yield is known to be 19 grams. What is the percent yield of magnesium oxide? So in the problem, the theoretical yield is already given. In some cases, where the theoretical yield is not expressed, so we have to calculate for it using the steps that we had demonstrated earlier. So how do we compute for the percent yield? So percent yield, so we have 15 grams of magnesium oxide divided by 19 grams times 100. So the percent yield is equal to 79%. All right. So let us summarize what we discussed today. So the limiting reagent is the reactant that gets used up during the reaction and also determines how much product can be made. We can find the limiting reagent using the stoichiometric ratios from the balanced chemical reaction along with the many methods. Once we know the limiting reagent, we can calculate the maximum amount of product possible, which is called the theoretical yield. Since the actual amount of product is often less than the theoretical yield, chemists also calculate the percent yield using the ratio between the experimental and the theoretical yield. So let us finish this tutorial session with a 5-question assessment. So number 1, it is the reactant that is used in the reaction. A, excess reactant. B, percent yield. C, limiting reactant. D, cofactor. And the correct answer is limiting reactant. Number 2, which of the following describes the relationship of the number of moles and mass of reactants and products in a chemical reaction? A, molality. B, stoichiometry. C, balancing equation. D, percent yield. Ang tamang sagot po ay B, stoichiometry. It is the maximum amount of product you would expect from a reaction based on the amount of limiting reagent. A, theoretical yield. B, limiting reactant. C, excess reactant. D, product difference. Ang tamang sagot po ay theoretical yield. At yan po ang ating tutorial session para sa linggong ito. Binabati ko po ang aking mga kasamahan na Microsoft Education Ambassadors who had just passed their respective Microsoft Certified Educator Examinations na si Ma'am Serena Galoy ng SDO Pasig at Sir Henry Nerison ng SDO Bohol. Congratulations, Ma'am Serena at Sir Henry. Once again, this is your tutor Lester for this segment. See you next week, same time. Happy Monday po sa ating lahat.